probability of getting 2, and so on. Now, disregard all this first stuff now, and just look at this experiment where you're tossing a coin. So if you're just tossing a coin, just imagine all this other stuff is gone. I'm just tossing a coin. So what's the probability of heads? 1/2. What's the probability of tails? 1/2. So each of these will have 1/2, 1/2 here. 1/2. 1/2. So now consider, just disregard all this other stuff. Just imagine you're going to draw a ball from this experiment. So what's the probability that it's red? 1/3. What's the probability it's green? 1/3. Let's draw 1/3. So let's find the probability that you get so let's find the probability that you get a 1 first, and then you get a head the second step. So the sample space of this experiment, the sample space is all the sequences you can form by joining these blocks of lines. So 1H, 1T, 2H, 2T, 3H, 3T, 4H, 4T, 5H, 5T, and then 6R, 6G, 6B. These are all the outcomes in the sample space. So if you want to find the probability of this outcome, then, so if you want to find the probability of this string, you take the probability of this first, so you're looking at this first step, you take the probability of that 1 occurring, so that's this number here. Right? So you take, look at this probability 1 omega naught of 1 times probability 2 omega naught omega 1. So it's omega naught and then 1 actually. So 1 is what omega 1 is. And then you find the probability of x there. So this first probability is just this 1/6. This is 1/6 here. And then the second probability is this 1/2. Okay. So this 1/6 is coming from here. And this 1/2 that's here. So what's the probability of let's say I want the probability of let's say it's now I want the probability of 6 and then blue. So this is ordered pair 6B. So this would be, so it's, you take this probability 1 of omega naught of 6 times probability 2 omega naught 6 of blue. So you take the probability that you get a 6 in the first step, that's 1/6. Times the probability you get B in this step, so that's 1/3. Do you guys have any questions? So, this is what I mean when I in Reynolds standard stuff. It's just you take the probability of this first event occurring in that first step times the probability of the second event occurring in the second step, and so on. Just multiply these out, and that'll be the probability of that string of outcomes. So I think on the homework, so here's the point of this example. So this compound probability function, it's not egalitarian. So a probability function is egalitarian if every single outcome in the sample space is equally likely. So if every outcome has the same probability, but here you have these two outcomes. So this outcome 1H and this outcome 6B, they have different probabilities. So this compound probability function, this is not egalitarian. Okay? Even though each of these sub-probability functions is egalitarian. Okay? So even if the compound probability function is not egalitarian, we still use the compound probability function. As the default. So, even if, so in this case, this compound probability function wasn't egalitarian, but we're going to use it as a default probability function anyway. I think on the homework there's a problem where they roll two die, right? So instead of flipping a coin or this stuff, they'll have you roll a die first and then roll a die again. Okay? And they'll ask you for the probabilities of some events. So I typed up that problem in the notes. So if you have trouble with that, it's typed up in the notes. And for that problem, the compound probability function will actually be egalitarian. So if they ask you for the probabilities from events, so if you roll two die and they ask you, like what's the probability that the sum is 5, then the compound probability function there will be egalitarian. So all you have to do is count up the number of paths that would add up to 5. So let's say there are 12 paths that add up to 5, then the cardinality of that event would be 12. Does that make sense? So if it doesn't make any sense, just look at the notes. I typed that problem for you. Okay? I think there's a homework due tomorrow, right? If you guys have questions, you can email me like tonight. Okay? You guys have any questions on this? Okay. You guys can go.